So if I have this 1, 2, 3 and 4, 5, 6 here, the repeated 1, 2, 3 here in the transact table, it will be laid out as first row, 1 Kate 12, 1 row, that's 1, will be paired with 1, 2, 3, 4, 5, 6, 7, 8, all the rows. So you see that here. So 1 Kate 12, 1 row is being repeated 8 times, right? Because that's all combinations of the other rows. Then the second unique row here, 2 bill 4 orange tree, is, as you guessed correctly, being paired with all 8 rows in the transact table to come up with the outcome of 8 more rows. Yeah, 8 more rows in the final cross table outcome. And then 3 Mary 3A Bench Avenue is going to be repeated 8 times, right? With pairing with or combined with the unique rows from transact table. So there you have 3 times 8, 24 rows in the cross join transact table. Okay, so cross join requires 2 tables. Table 1 cross joined with table 2. Same thing goes for inner join. So it's table 1 join with table 2. Now what does this bring us? What does this bring us? This concept basically says your answer must be somewhere inside the cross table. Okay, because in a grid, in the XY axis, all possible combinations are there already. It has to be one of the point in the table, right? So same thing here, same concept goes here, in the sense that when you ask for some query that originates from customer and transact, that means the result you expect to come from a combination of these 2 tables, then the answer has to be lying somewhere in the cross product of these 2 tables. That's the underlying principle. So let's suppose we say a more business-oriented question. What is the customer name? Name, I want the name, not the ID. What's the customer name with the highest amount in single spending? Single spending, one spending. Remember the same customer might have spent a few times at the same or different restaurants, right? So what is the customer name with the highest amount in single spending at any restaurant? Okay, how do we answer this query, this question? This question could come from the boss. Who's the customer name with the highest? Maybe we should give you a surprise, or maybe we should arrange a special invitation card for VIP. So who? And then after knowing who, you can know where's the mailing address. So first of all, how do we decide or how do we find this customer? So answer must lie in somewhere involving spending, which is the transact table, and the customer table, because then we know the name, right? The name cannot come from the transact table. We only have the ID, right? So if we cross them, customer cross join with transact, answer must lie somewhere. Of course, we can eyeball it. We can search for the amount, right? And say 128, and then identify. But can we do it programmatically using SQL? So answer is, of course, yes. All right, we can cross join, producing all possible combinations of everything. But of course, we don't want all of them. We want rows where the customer ID has the same ID as the transact table. So rows that make sense to us in this query only comes from those where ID is the same as ID colon 1. For the sake of uniqueness, the cross join select automatically modified this ID and spelled the same way as the ID in customer table into ID and ID1, depending on which one comes first. So doesn't matter, we can always alias this to something else. But the idea is 1 and 1, customer 1 kit and customer 1 spending. That makes sense because that refers to customer to Kate. But customer 1 Kate related to customer 2's spending and boogies, that's Bill's spending. And there's no relationship, assuming they are not related. So that doesn't make sense. And even if they are related, maybe that's a group kind of membership, then we should have a group membership ID or something like that, right? So basically they are not related. So 1, 2, 1, 3, 1, 4, they are not meaningful. It's mathematically possible, logically possible to access them, but business context wise, it's not meaningful. So how do we get rid of them? Very simple. We filter from this temp table and say that this ID, the blue ID must be equal to ID colon 1. Then we will filter off all the rows that are not having same IDs, right? And correctly dropped off. Then we do something else. So that operation is done here. So we say select from this cross this where customer ID customer dot ID. So it uniquely refers to table dot column, right, equal to transact dot customer ID. Okay. It'll be wrong to say customer dot ID equals transact dot ID, because the transact dot ID is the primary key to transact. What we want is the referencing ID, the one that uses the primary key, is being equated with the primary key. So transact dot customer ID, which is the foreign key, is equal to customer dot ID, the primary key. This is how we end up associating primary key with foreign key in the equal constraint here. Okay, so when we do this, what happens? We throw off all the rows that don't have the ID being equal to customer ID. Right? So not ID colon 1. We don't care about the ID colon 1 because it's transactions ID, it's created on its own. But what we care about is the ID, customer ID being equal to the transacts customer ID being equal to the customer dot ID. And this is what we see here, which is good. And we are still continuing on because we're not done yet to want to find the highest amount. But then it's clear from here now, we can say, because Kate can spend 5 times, but they're all small amounts. And Bill spends transacted 3 times. Kate also transacted 3 times, but Bill's spendings have always been, smallish, and Kate's spending is, sometimes low, sometimes high. So, but doesn't matter because our business query was which single transaction was the highest by whom. Now, before we continue building onto this, let's just understand the interaction between cross join and inner join. What's the relationship? Now, because cross join is union combination, right? So all combinations are there. And inner join is kind of intersection only when the column values match, which is exactly our case here. So what we can do is that inner join will be also usable here. And we say select this customer, inner join with transact, and inner join requires an on to make it very clear that you're inner joining. So inner join requires you to have a column that is whose data value is being matched. So customer.id equal to transact.customer ID. Same expression. Except the where becomes on and cross join becomes inner join. Now, since we can do it both ways, why do we need 2 ways to express the same thing? We'll get back the same exact temp table. Why do we need 2 ways to do the same thing? Logically, whatever inner join can be done, the answer also lies in cross join, because we did say that cross join produces a cross product that contains all possible answers, whether it's meaningful in the business context or not, or everything is there. The search space is very huge and definitely contains the answers given by inner join. So whatever inner join can do, cross join can do so too. Then why do we need both? And of course, the answer lies in readability and clarity of the logic. When we do this kind of customer transaction cross-referencing, which is a lot, right? Imagine bank account, bank account holders with the bank accounts, and there can be 5 bank accounts, and each account can have a lot of transactions, and some may not have much transactions. So a lot of times when we run membership, when we run chain restaurants, when we run business, companies, events, and rewards, and plenty of situations in the commercial world and even personal lives where we do this inner join. Yeah, customer ID cross-reference with transaction ID. So because of that, it makes the intent, the intention of the SQL programmer much clearer when you do use inner join in such an occasion. And you say, actually, I'm trying to align the values together to process it from there on. I'm not interested in the, customer one linked with customer five, that kind of combination. So when you need to do that, an inner join straight away says that. But cross join may not be, because until you understand the whole filter, which in certain circumstances allows you to get customer 1 ID equal to customer 3, 4, or 5 IDs, something like that. Because the where is anything, you can say anything. And it can be less than, it can be greater than, whatever. So yeah, one will have to fully understand your complicated logic here and your filtering condition before one can say, oh, I see, I could have just shortened this to inner join, right? So the inner join is clearer, it's logically more expressive, and clearly spells out the intent that we want to get this primary key aligned with that foreign key. That's very, very clear here. All right. So just want you to be very clear. Once you're clear here, you understand why certain SQL codes, you suspect you could have used inner join. How come that programmer uses cross join? It may be because it's a logic that is handling really certain unexpected cases, or it could be that the original SQL programmer didn't know, and that's why he or she experimented with cross join because it's the most all-encompassing temporary table, right? So found that you can restrict the filter that way and then get your result, but without telling future SQL reader of that code that it's actually amounting to an inner join. So just be aware of these cases. Okay, so now that we have this temp cross table, what do? We still have to answer the question. Yes, basically by performing a sort, because up to that point where we get customer ID equals to transact dot customer ID, we don't know what is the max. The max can be $900, $50, we have no idea. But when we sort using order by descending, that means the highest amount first, right? We will get a sorted table where we have 128.5 as the first row, and then we limit by 1, we will get just one row like this. Okay, and then of course this is clear. Whether we extract the address or name is up to us. So we extract everything from this temp table.